Okay, guys, so we are going through the FHRP protocol. Okay, just a second. Let me plug my pointer. Okay, so we are going with the FHRP topic, which is called as first hop redundancy protocol, and it consists of three major topic: HSRP, VRRP, and GLBP. Okay, the first two are meant to work as a active standby state. The first two protocol, HSRP and VRRP, they work on a model active and standby. That means one of the device is going to serve the traffic and the second one is going to be standby mode until or unless this goes down and the re-election happen, and then this takes up the role of active. Okay. GLBP is used for load sharing when you can have both of your devices serve the traffic. Okay. So we will go across each one of them. From our previous class, we have completed HSRP version 1. Okay. So in today's class, I'll take it forward. I'll go with V2 first, and then we will discuss about VRRP, and might be in the next class we will go up with GLBP. Now, for someone who is joining the class for the first time, let me tell you where do we use this protocols. Okay. So the best practice always say, the best network practice always say that don't rely on a single device or a single point of contact. Okay. So let's say if this is a network enterprise, let's say I have a PC user, I have a Cisco switch, I have a Cisco router, and which connects to ISP. Okay. So the drawback of this kind of design or a network design is they are all falling under a single standalone point of failure. Okay. If let's say if this box goes down for some reason, your user is disconnected, the user is isolated from the internet connectivity. Okay. Might be this user was sharing some file to a customer, right? Now this brings up the network or the protection loss due to the bad network design that you have in your enterprise. So what is the best practice? The best practice is let's have some redundancy. So I would connect an extra device here, I would connect a extra router here, and similar way, instead of relying on single ISP, I would have another ISP acting as a backup uh, ISP point, or a backup ISP. Okay. So now what happens in case this goes down, we still have the second device which can take up the role of forwarding the packet, and we still have the connectivity. Okay. So how is HSRP and VRRP going to help us? So let's say I have two routers. Okay. And the routers are connecting to internet service provider, and let's say I have a switch and the switch is connected to a PC user. So let's say by default the packet are being taken up by router 1. Okay, let's say the gateway or a router 1 is forwarding the packet. Okay, so his data will be sent to the switch is going to switch the packet to the router, and router is going to take it forward to ISP. Now, for some reason, let's say this goes down. So what is going to happen? Your packet is still pointing towards this gateway and your packet is still getting dropped. The reason is you have lost the connectivity and there is no way the packet can go further. So what I'm going to do is I'm going to have some redundancy protocol enabled. So I'm making use of HSRP. So how do HSRP work is I'm going to create some virtual IP address, and as soon as I have a HSRP started up, it's going to bring up a MAC address. Okay, so this MAC address will be loaded up on this switch, and this virtual IP will be the gateway now, the new gateway for the computer to send the packet. Okay, So earlier the PCs were sending to the physical IP. So let's say the physical interface IP is 1.1.1.1, and let's say the physical interface IP over here is 1.1.2. Now this used to be the gateway for a computer. Okay, but once you bring up HSRP, you're no longer going to have your physical interface. Okay, you're going to use your virtual IP. Let's say now the gateway becomes 1.1.1.3, which is neither this interface, neither this interface. So you're going to send a, you're just going to forward something over on this. Okay, and over on the switch you have the HSRP MAC address. Now the MAC address know whom to send, whether shall I send to this router 1 or shall I send to this. Okay, so that's how the decision would be made up. In case of any failover, let's say this is down, now the switch will remove the entry which is pointing to the R1, and it would make a new entry pointing towards R2. So this is one benefit of having HSRP on the LAN side, local area network. Now at the same time, let's say on a ISP side, okay, so let's say if this interface for some reason goes down, so by default your packets are pointing on this direction. Okay, let's assume the packets are being pointing to this direction, but this is down, right? Now that could lead to outage. Okay, but thanks to HSRP have an additional feature where it can track the object. So what are we going to do is we are going to enable some tracking object on this interface. So as soon as this goes down, the tracking gets enabled automatically, and it's going to say that this router has an interface down, and let's re-elect, and now this becomes standby and this router becomes active, and your packet will now start moving on this direction. So HSRP as all together, it will take care of LAN as well as WAN. Okay, so let's say you enabled HSRP, it's going to take care of your LAN traffic or the LAN direction. Also, it's going to take care of your WAN direction. Okay, in case of any failover over on the WAN, it's your HSRP who will re-elect or reconvergence, and the election will now make this as a active device. So your packet will be forwarded on this, and the traffic will be going out of this. Okay, so this is a general behavior of HSRP and VRRP. Now we learned about the configurations. How do the packets flow across on HSRP? What is the difference between version 1 and version 2? So that's something which we need to check. And okay, so let's walk through the lab, and let's also get this done practically. So I have my topology started up. So I was considering these devices. Okay, and I have the console of the routers. So I have console for router 19, and as well as I have a console for router 20. Okay, by default, how is the traffic flowing? So let's check it out. So my PC 10 has a gateway of 10.1. So 10.1 is a physical interface IP. That's nothing but it's a IP address of this interface. So I have not configured HSRP yet. I just want to show you pre-packet flow, and once you configure HSRP, the post configuration packet flow I just want to show you. Okay, so let's ping one of the IP. Let's ping 8.8.8. So I believe this packet is flowing in this direction. Okay, that's a default behavior because my gateway is pointing to dot 1, so it should forward to dot 1. Okay, now the issue is if this physical interface goes down all of a sudden, if this physical interface is going down. So let me bring it down. Okay. Do we still have a packet flowing? No, the packet got stuck. Now we are isolated. Now there is a outage happening here. My users or my server, it doesn't have any connection to the internet. Okay. Now this is where you need HSRP. If let's say you have HSRP enabled, the election would have happened and your traffic would have been taken up on a different path. Okay. So let's do that. So let's configure HSRP and let's analyze the packet flow. Okay. So over on interface 1.0 I'm going to enable HSRP. The command is HSRP and I need to give some group number. So let's say for VLAN 1 I'm going to give group number to be 1. And what is the IP address? Now it's asking me for an virtual IP address. So let's make use of this IP that is mentioned over on my screen. Okay. So this act as a virtual IP for VLAN 1. Let's make use of preempts. Now you know what is preempts, right? Let's go with some priority. Let's go with priority 1110. So by default the priority for HSRP is 100. Let's go with 110 because I want this device to be the active device for VLAN 1. Okay. So just 3 commands which should bring up the HSRP. Okay, so let me just write it over here. It would be easier for me to copy paste. Okay, so standby 1, let's define the IP address. Standby 1 preempts. Standby 1 priority 1110. So this will go on the first interface. Okay. So similar way I have to configure it for VLAN 40 as well. So that's over on sub interface dot 40 and the IP address becomes 172.16.40.254. That's again printed over on my screen. Let's give a priority 110. So let's copy this and let's bring it over here. Okay. And similar thing will be put up on the second device, but we just need to take down the priority because by default the priority would be 100. So let's remove priority and put those other remaining commands over here. Fine. Okay, so let's verify the HSRP status now. Okay. Okay, so this has taken the active role and so the VLAN 40, the HSRP 40, group 40 has already taken up the active role and let's see from the second device point of view. Okay, so this becomes active local. So this is fine. I feel this configuration is not proper for 1.1. Okay, so let me once quickly verify what's not over here. Okay, it's under shutdown mode. So let's bring up that. Okay, so the election have been successfully done. So it's going through the HSRP states. So what are the HSRP states that we learned in the last class? It's init, listen, speak, standby, and active. So these are the states which HSRP will go through before it elect itself as standby or a active role. Okay, now it has taken up the active role. So this device with this router Moscow R19 becomes an active for VLAN 1 as well as for VLAN 40. Okay, at the same time the second device becomes a standby for both the VLANs. Now let's play around with the packet flow. So to achieve any sorts of HSRP behavior, in order to test the HSRP traffic behavior, make sure you edit the gateway now. Okay, so your gateway should not point to any physical interface. It should point to the HSRP virtual IP. So I'm going to make it as 254. Okay. So where is 254? Basically 254 is configured on both the routers. As of now, this has taken up the active role because of the highest priority. If this goes down, the re-election happen and then this router takes up the active role. So let's see that behavior. So let me just power off this instance because I just changed the IP address. Whenever you do any changes with the IP address, you need to stop and start that instance, okay, to take up the new configuration. Okay, so let's give a test. Let's ping one of the IP. I have reachability. Let's check it out on which direction is this packet flowing. So it's taking over on 10.1. 10.1 is nothing but over this. Okay. So your packet is flowing across on this direction. So that is a known behavior. The reason is this router is acting as active at this moment. Okay. Because of the 110 priority that we configured here. Now let's say for some reason this is down. So I'll bring down the interface. So let's say over on the router 19, let's bring down, okay, and let's give it try now. Let's first ping. I still have the reachability. What about trace route? Let's find out how is the traffic going now. So now it took the second path, that is 10.2, and where is 10.2 configured? It's configured here. So now the traffic is flowing across in this direction. So this is a HSRP behavior. Okay, so it's giving you redundancy in your network design. So in let's say in a non HSRP scenario, the gateways were pointed up to this physical IP and it used to take this path. Due to some outage, let's say this device goes down or this device goes down, or let's say this cable goes down, your traffic is still pointed across to this, and since you have a network failure, a failover, let's say you have some network components that's failed, so your traffic will be still stuck. Okay, there is no way that this PC is going to take up the second path because you have no redundancy protocol in your network. Now as soon as you bring up HSRP, you're bringing up the virtual MAC address, you're bringing up the virtual IP address. So these are the two introduction that you're introducing in your network as soon as you bring up HSRP. Okay, and now what happens is your gateway is mapped to the virtual IP, and in case this goes down, you still have a redundancy path. And if you check it from the switch point of view, that's switch number 1. If I show you the MAC address table, so you can see the new HSRP MAC address has been enabled. And where is it pointing to? It's pointing to 0/1. So this HSRP is now pointing to this because the traffic is now leading in this direction. And also if you observe the HSRP MAC over on this switch, it will be pointed to these two units or these two interface. So that's how the decision is made over on a L2. Because let's say your interviewer ask you tricky question here. Let's say he asks you that since these are the computers which are not directly connected to the routers, so how is the decision being taken up that this is down and so let's forward it on the second path, right? It's because of the MAC address table that's getting built up on your switches. So the MAC address now says that the MAC address is now getting associated with the forwarding path, and that's how your packet is flowing across here. So that's a default behavior of HSRP. Now HSRP version 1 supports IPv4 only. Okay, so we also have one more version which is called as version 2, which supports both V4 and V6. Okay, and they are not backward compatible. Uh, that means let's say you have version 1 enabled here, and if you have version 2 enabled over on this side, now they both will not form a single group. They are different protocols now, or they are going to work in a different pattern. Okay, so they are not backward compatible. As in VTP, we have seen in VTP, when I have VTP2 and VTP3, basically the switch with VTP3 will send both the advertisement. So let's say in a case of VTP, virtual trunking protocol, if I have version 3 enabled here, and let's say I have the second switch which is configured with VTP version 2, and I had another switch with VTP version 3. Now this switch is going to advertise VTP packet version 3 for another VTP3 switch. But in this case, since this is a version 2, it's going to advertise the version 2 packets. Now VTP3 will be called as a backward compatible because it is going to take care of the version 2 as well as version 3. But in the case of HSRP, that's not going to happen. Okay, your version 2 is not backward compatible with version 1. So you need to have different groups, different VLANs and different concept. Okay, but yes, one thing is, let's say you have a switch, you can configure version 2, HSRP version 2 for VLAN 40, let's say over on this interface. But at the same time, you can have HSRP version 1 for VLAN 1. So that is possible. Okay, let's say your one switch has 2 or 3 VLANs, and as per the VLAN, you can change the behaviors. So that's going to work, but that's little complicated because you have to maintain the consistency throughout the network. So just go with one version instead of mismatch and leading to all confusions. So let's see how do we configure version 2 and what is the benefit of version 2. Okay, so let me first write down some key points of version 2. Why must someone go with version 2? So first point regards to the timers. Okay, your HSRP version 1 has by default 3 seconds for hello timer and 10 seconds for a hold timer or a dead timer. Okay, but in the case of version 2, they are going to be in milliseconds. Okay, much more faster than your version 1. So your version 2 has a millisecond support. The next thing about version 2 is with respect to group numbers. So over on version 1, it's going to support only 255 groups, whereas your V2 is going to support up to 4095. Okay, 0 to 495, and this is just 0 to 255. Now because of this support, your MAC address will also be a little different. Okay, So what is the default MAC address format for a version 1? It's uh, okay, let me write it down. Okay, so it's going to be this format. Okay, and what is this? This is nothing but in a hexadecimal notation. So let's say for VLAN 10, what is the expected HSRP MAC address that's going to auto generate? It's going to be AC0A. Why did I get 0A? The reason is, if you just convert decimal to hexa, okay, your values are going to get converted to hexa and get stored in your MAC address. Okay, so that's how the MAC address is calculated. But in the case of V2, due to large number of groups supported, now this is not something which cannot be used. Okay, so in case of V2, it's in a range of this till this. Okay, so if I just write it, the complete MAC address, so your MAC address will be in this range. And let me tell you how do we calculate it, how do we calculate. So let's say from the last group point of view, if I just try to convert 4095 into hexa value, okay, so 4095 to hexa. So what is the value? It's going to be triple F. Now let's see that. Okay, so that's what I have stored here. So this is the last possible MAC address in case of HSRP version 2. And what is the first one going to be? It's going to be all triple zeros. Okay, so this is a range of MAC address in the case of version 2. The reason is you have a broad range of groups under V2, whereas in version 1 it's only 0 to 255. So let's see what is the hexa for 255. 255. Oh, it's going to be F and F. Okay, which is again which is just a 2 bits. Okay, so you can easily make use of this MAC address for your 255. Okay, just let me write it over here. So in the case of version 1, the MAC address is going to be ranging from 09F AC00 till ACFF. Okay, it's just a 2 bits. In the case of version 2, since we have a large number of groups supported, now what is the hexa of this going to be? It's going to be in the 3 bits. Okay, so that is why your MAC address will also be little different than your version 1. Fine, so that was regards to MAC address difference. So now let's check it out from the packet level. Okay, so in the case of HSRP version 1, the troubleshooting is little complicated. Okay, the troubleshooting is little complicated in case of version 1. The reason is they are going to carry the virtual MAC address. Whenever your packet is traveling from source to destination, the packet will contain a MAC address, and this MAC address will be of a source, or it will be of a HSRP MAC address. Okay, now this HSRP MAC address can be over on any interface. So let's say from the topology point of view, in the case of version 1 MAC address, the MAC address can be seen over here, and the same MAC address can also be seen over here. Now how are you going to troubleshoot that the issue is over on this or over on this, right? That is why the troubleshooting becomes little complicated in case of version 1. Whereas in the case of version 2, it's going to have a unique identifier which is called as identifier. Okay, and this identifier is going to carry one more MAC address, and that MAC address will be of the originator. So let's say the HSRP packet is from switch number 1. So the MAC address of this switch will be stored in this packet, in the Ethernet packet. And now we can easily troubleshoot. We can easily find out whether the issue was over here or it's over on the second switch. Okay. So from the troubleshooting point of view, version 2 is much more easier because it has a additional identifier component which will help us to understand where this packet is originating from. Okay, regarding the multicast address in the case of, okay, regarding the MAC address, multicast address. Okay, in the case of version 1, it's 224.0.0.2, but there is a overlapping protocol here. There is one more protocol which is called as Cisco Group Management Protocol, CGMP. Okay, now let's say when you have HSRP version 1 enabled, your this protocol cannot be functional. Now that's something related to the technical fault. Okay, it's not that we have done this or because of our network design or something. That's a glitch while launching this protocol. They have not taken the proper precaution, and because of that, this multicast address is overlapping with this protocol. So this protocol also has a similar multicast address. Now what happens is, if you are running on HSRP version 1, now this protocol will not work. So this has been taken care in HSRP version 2. The reason is the multicast now is this. If you just check out HSRP version 2 multicast address, now that's 224.0.0.102. Now in the case of version 2, you can parallelly run the CGMP protocol as well. Okay, so this is some protocol which is used for some other features, but when you have version 1 HSRP, now they both will not run at the same time. So that's one more reason why you should go to the version 2. Okay, so the MAC address was discussed. Okay, and let's say we are running on HSRP version 1 already, and if I just migrate to version 2, so I just need to put one extra command saying standby 1 version 2. Now this is going to enable version 2 for me. Now what happens is, in the back end, your re-election will happen. Okay, so let's say already the election was happened. It has gone through the states: init, listen, speak, and then it decides whether to be active or to be standby. Okay, so as soon as you change the version, these states are going to repeat. The reason is your virtual IP is getting changed, as well as your virtual MAC address is getting changed. You already know what is a MAC address behavior in case of version 1 and in case of version 2. Now they are a different MAC address, right? This is a totally different MAC address, and in the case of version 2, that's a different MAC address. So as soon as you change the version, your re-election will happen, and then it's going to find out which is active and which is standby. So the behavior is same in case of version 2. By default, preempts will not be enabled. You need to allow that. and the priority makes the decision. So the behavior is same as version 1, but there are a couple of differences or a additional point in case of version 2. Okay, regarding the packet structure, in the case of backward compatibility, okay, so we know that version 2 is not backward compatible with version 1. The reason is the packet structure of these two. Okay, in the case of version 1, the packet structure will only talk about protocol. So let's say the protocol is shown as HSRP, and it's going to show the version as 0. The 0 is nothing but version 1 in case of uh, HSRP. But in the case of version 2, the packet structure is not similar to version 1. Okay, it's going to have an additional component which is called as type. Okay, and this type is going to get integrated with your protocol and the version, and that's why they are not compatible, because these are easily detectable that this is a part of a HSRP version 2. Okay, because it is integrating type 1. So the packet in version 2 is called as TLV, type length value. Now this is because of this additional concept, your protocol whatever you're running is getting integrated with your TLV value, okay, the type value. In the case of version 1, you do not have those features or those things here. That's why they don't form backward compatible, because whenever a version 2 is sending the packet to version 1, it will be not able to recognize what is type, because that's not the behavior of version 1 packet. Version 1 is just a plain packet. Okay, fine. And regarding the similarity, both are going to run by default on plain text, but you have the support of MD5. Okay, they are going to have the similar kind of states, that is init, then the listening state, speak state, and then they decide who is active and who is standby. Okay, so these are few similarities, and those are few the differences between the two of them. So let me once go through this. Okay, the object tracking is also very similar. So object tracking is a feature where you can track your WAN phasing interface. So that's again similar thing in both version 1 and version 2. Okay, so on the notes you will find all the points discussed. So after the class, go back once again and just read it out. Or let's say you're preparing for interview after 2-3 months, this notes would be really helpful for you guys. You just can refer back. Okay, so I have tried to put some Wireshark capture as well, so that you understand what is what. Okay, so as I told you, in the case of HSRP version 2, it's going to have an additional field called as identifier. Okay, and because of this identifier field, the troubleshooting becomes easier. Okay, we just can track this MAC address, and we can find out which switch is having the issue. Okay, in the case of version 1, we don't have this identifier field in the packet uh, inside the packet. Okay, and similar way, the TLV that I was talking about, this is type length value which is seen in version 2, and it's going to add type 1 along with version 2. Okay, so that's a behavior in the case of version 2. In the case of version 1, we do not have TLV format. It's a plain format, which might be I have shown you in the last class. So in the version 1, there is nothing called type getting associated with the version. But in the case of HSRP version 2, the TLV, the type gets integrated or associated with group 2. So that's the reason why they are not backward compatible. Now if version 1 receives something, some format, some structure which is little different, now version 1 will not be able to identify the things. Okay, now what is TLV? It's nothing but it's storing data to facilitate quick parsing of the data. Type is T for type, L for length, and V for value. Okay, and what is what, it's all mentioned. What is the byte size, what is the ASCII format. Okay, so this is not required from CCNP point of view, but yes, if you know a little bit on TLV things, it's good, because this TLV will be repeated for some more protocols. Okay, let's say if you guys know what is CDP or LLDP, Cisco Discovery Protocol and Link Logical Discovery Protocol. So these protocol also work on TLV concept. Okay, so from that point of view, just have little bit of knowledge, and I think this is going to work. Okay, you don't need to know anything more than this. Okay, fine. Regarding the configuration, it's just a single command which should bring up your version 2. So let me quickly do that. Okay, so as of now, on which version am I running? I'm running on version 1. Okay, so how do I see that? So I have version 1, which is by default configured. Okay, and let's change the behavior. So on VLAN 1, let's say, let's give us an task. So let's say I have VLAN 1 and I have VLAN 40. So both of them are running as of now on version 1. So I'll make this on version 2, and let's keep this as version 1. That's possible. Okay, that's possible. But on the second side, you cannot have version 1 for VLAN 1. Now that is not possible. Okay, so you need to make it version 2 in the to have a consistency. Okay, in the case of 40, you still can have the second device on version 1, but you cannot bring version 2 there. Now that's a mismatch. Okay, so from the individual VLAN point of view or individual group point of view, you have to maintain the consistency. Okay, but between the groups, different groups, you can have your own version running up. You can have version, let's say you have version 1 running up over on VLAN 1, and similar way you want to have version 2 for VLAN 40. Now that's possible. Okay, but you just cannot have the other way around. So let's make version 1 as let's make a VLAN 1 on version 2. Okay, so I'll go to interface E 1.1. I call standby 1 version. Okay, so the command is standby version 2. Okay, and if you want, I will enable some debugs for HSRP. Okay, and from the second device point of view, let's go to interface 1.1. Okay, and let's make it standby version 2. Okay, so the reprocess or the restate election is been happening. They are going from the init state to listen state and speak, and then they are going to decide who is going to be the master and who is going to be the active and who is going to be the uh, standby. So show standby brief. Okay, so the second device was marked shut down. So let's bring up that. So this was shut down when I was demonstrating the packet flow. So I'll bring that up. So let's see what is the output now. Show standby brief. Okay, so it has taken the standby, and we also have this router acting as standby for VLAN 40. The reason is we have the highest priority configured on this router. Okay, from the version point of view, let's see show standby. Okay, So for show standby, I see that it's over on V2 now. Okay. In the case of VLAN 40, it's still on version 1. What is the MAC address now? So for a version 1, this is the MAC address. Now this is a hexadecimal format. Okay. So this is a hexadecimal format and it has taken up this. So basically your group is, the group number plays an important role to find the hexadecimal. So your group 1, if you just convert this decimal to hexa, it's going to be 0 1. Let's see from version 2 point of view. So for version 2, that's, this is the MAC address. Okay, the MAC address is different for version 1 and version 2, and because of this reason only the re-election is happening, the init, listen, speak, active standby, because that's the time when the switch will do the MAC address formation. So if you see from the switch point of view, you will see both the MAC address getting associated. So you have your version 2 getting associated for the VLAN 1, and you also have a MAC address for VLAN 40. So that's how the traffic is getting switched. Okay, so this is how your MAC address is switching the traffic to the upstream routers. Okay, now let me open up the Wireshark and let me show you the difference between the version 1 and version 2 packets. So over on this interface, I should be able to see both the HSRP packets, right? So I have the version 1 as well as version 2. So in the case of version 1, if you see, I do not have an additional component called as identifier, but I open up version 2, I will have something called as identifier. Now what is this MAC address? So let's quickly troubleshoot. Okay, so I'm going to copy this first. Okay, I'm going to my switch and I'm just going to do some troubleshooting. So let's say this is a command to find this out, and it clearly says me that this is a MAC address that's associated with this interface. So let's find it out. Okay, so this is the interface 0/1 where this MAC ID is being learned. So if I check my diagram, okay, so I'm on Moscow 2, that's this switch, and where is that target MAC address being read? It's read on 0/1. Okay, so that's nothing but it's pointing me towards this person, right? So let's give it a try. Let's go to that router and let's find out what is the MAC address of that. So that took me very simple approach to figure it out, right? So let's quickly check that. First let me turn off the debugs there. Okay, now let's check what is the MAC address of 0/1. Okay, 1310. So is that the MAC address what I'm trying to find out, right? So this is 1310, right? So what is this MAC address? This is a MAC address of R20. Okay, and that MAC address is now associated with your HSRP V2 traffic, and that's how the troubleshooting becomes easier for someone over on version 2, because you have this additional field. In the case of version 1, you don't have this. You have to do some extra step to find out the culprit, but in case of version 2, it was pretty simple. The second thing what I was trying to tell you was the TLV concept. Okay, so time length value, this is how your packet is grouped in case of version 2. Okay, so your type 1 get associated with version 2. Now in the case of the version 1, you do not have any component called TLV. Okay, so you don't have that TLV component in the case of version 1. So that's how they both form different packets and they are not going to recognize each other. Okay, and what else? So from point of timers, they are running on milliseconds. So that's what we discussed. HSRP version 2 is going to support the timers in milliseconds, whereas HSRP version 1 is going to support just in seconds. So you see this 3 seconds and 10 seconds, but in the case of version 2, they are 3 milliseconds and 10 milliseconds. So that's one more difference here. Okay, fine. So we are good with version 2 and we are good with version 1. So if you need, I can test the connection, the packet flow. So let's see from PC10, okay, which is a part of VLAN 1. So let's see how is the traffic being sent. So we have reachability, that's good. Let's try out the trace route. Okay, so it's pointing to 10.1. That's nothing but this. So that's fine, okay, because it's an active device at the moment because of the highest priority. Now let's say I bring it down. So let's see how much time it takes for the device to recalculate and reconverge the traffic. So let me put this shut. Let's give a quick ping. Okay, so let me see what is not proper. Okay, so let's see the gateway first. So this is fine. It's pointing to the HSRP virtual IP address. So this has taken up the role. Okay, so this has taken up the active role, which is again good. So let's see why is ping not working. So this is the MAC address which is associated with 0/0. That is great. That's pointing to the second switch. Let's see the second switch. So second switch is now pointing it towards. Okay, so that's also fine. Okay, uh, ping may not be working, might be because of the GNS glitch. Let me give a try doing a trace route. So let's see where is the packet taken up. Okay, so from the packet flow I can see it's working fine. So the ping may not be working, might be because of the GNS glitch. So if you see now, as soon as I made this interface down, it started pointing to 10.2, and 10.2 is nothing but it's a interface IP of this the second router. Okay, so that's how we just see that the behavior of the packet flow is very similar with version 1 and version 2. Okay, fine. So before going to VRRP, I'll just unmute you guys. So if you guys have any doubt, please let me know, and then I'll go ahead with the version. I will go ahead with VRRP. So any doubt?
Hello?
Okay, so all is fine.
Yes, I have a question.
Okay.
Okay, I don't know, maybe you already explained it and I missed it. In case you have different VLAN, how you gonna, how the virtual IP gonna work, like the gateway?
Okay, so basically when you have multiple VLANs, let's take it as an example: VLAN 1, VLAN 2, VLAN 3, VLAN 4. Okay, now these each
Yeah.
VLAN will have its own gateway. So let's take it as an example: 192.168.1.0 is an gateway for VLAN 1. Similar way, this
Mm-hmm.
is a gateway for VLAN 2. Let's say similar fashion, I have couple of networks and I have user
Okay.
placed under each network. Okay, so they form a different networks now. So
Okay.
I have 4 networks. Now in the case of HSRP, I have to enable on each one of them. So in this case I should have totally 4 instances of HSRP running. Okay, and how do I configure is I just go to the device, let's say on the router, and if you just see my in the case of my configuration, I made use of two sub interfaces, right? So this sub interface was responsible for the first network, and this first network is nothing but for VLAN 1 and its own layer 3 IP. Similar way, I had a second VLAN which is 40. So in that case, I am still running another instance of HSRP with VLAN 40 mapped to its gateway. Now, similar way, let's say in your case, I have few more interfaces configured with its own VLAN, its own HSRP instance, and its own IP address. Now, each instances can have its own active and its own standby, which we can play around. So, let's say if I have two boxes, two routers, I can make VLAN 1, 2, 3 to be active on this particular device. In the same way, let's say I have 10, 11 and 12 VLANs, I can make these VLANs or these HSRP instance to be active on the second box. So that's a load sharing concept of in HSRP. So does that answer your question?
Yeah, kind of.
Okay.
Okay.
Okay, so you just have to play with the priority command in order to make the active feature enabled on these VLANs. Okay, the commands remain
Understood.
almost the same with few IP minor changes. You need to enable preempts and you need to play around with priority. If in case you want to have these active on this box, so get the priority higher than 100. So let's say you can have 110 or 120 or whatever. Now automatically these VLANs are going to be acting as active on the first router. Okay, so that's how we can have multiple HSRP instance for multiple VLANs.
Okay.
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 Thank you.
Yeah. Okay. Fine. So, any other doubts? Okay. So I take it as no, and let's go ahead with the next topic.
Sir,
Yes.
yeah, can we use any encryption?
Yes, we can use encryption. As I told, they are by default making use of plain text, but they are going to support MD5 as a authentication. Okay, it's very simple command. Let me just show you. If I go to one of the interface, let's say 0/1.1, I just have to bring up the authentication. So I have multiple authentication supported. I have a plain text, I have MD5. So that's how we have to enable this. But make sure whenever you enable this, on the other side also you have to set up this. Otherwise, there will be mismatch in the authentication. One side you have authentication enabled, but on the other side, if you might have missed it, now that would not bring up the neighborship.
Okay.
Okay. Okay, cool.
Okay.
So let's go back to the mute state and okay. So regards to the next FHRP protocol, that is VRRP. Okay. So in the case of HSRP, as we all know, it's a Cisco proprietary. Okay, and we call it as master slave model. One of the device takes up as a master and the second device or the second router takes up a slave or a okay, sorry, in the case of HSRP it's active and standby. So one of the router takes up the active role and the second router takes up the standby. And to have the load sharing, we just had this discussion few minutes back where I can play around with the priority and I can just make active and standby depending upon the VLANs. Okay, so in the case of VRRP, it's a open standard. Okay, and V2 is going to support only IPv4. V3 is going to support both V4 and V6. Okay, and again they are not backward compatible. So as we learned in HSRP, then regarding the elected role, now in this case it's master and slave. Okay, it's going to be called as master and slave in this case, but as per the function they are very similar with your active and standby. Okay, so when you have one device acting as master, so it's going to take the responsibility of forwarding the packet, and the second one is just waiting for its turn. So for some reason this goes down, the re-election will happen, and the standby will now become a active, and it will start forwarding the packet in the case of VRRP. Okay, regarding the states, okay, in case of HSRP, we just checked it. There are couple of states like init, listen, speak, active, or standby in the case of HSRP. Whereas in the case of VRRP, it's only three states, that is init, master, and slave. Okay, so what happens, your in terms of timers, your VRRP is much more. Okay, I felt there was some latency issue, so fine, that should be okay. Okay, so in the case of timer, because of this reduction in that states, your timer is much more faster in case of VRRP. Okay, the second difference between HSRP and VRRB would be, let's say in the case of HSRP, by default the preempts are disabled. Okay, preempts are disabled for both V2 and V1 and V2, whereas in VRRP preempts are enabled by default on V2 and V3. So you don't have to manually enable this, so you just need to play with the priority command to just make a master and slave combination, or just change the behavior of that. Okay, fine. So let me quickly walk through the notes, so that would be easier for you guys to refer. Okay, so let me zoom in. Okay, so I have written some key points with respect to VRRP. So I say that the first point is about the master and the slave. Okay, so backup router can also be called as a master and slave. Okay, in the case of VRRP, the preempts are by default configured. The MAC address of a VRRP is going to be in this format. Okay, so your version 2 is going to support 255, and then the version 3 will support all the 4095. So as of now, this is the MAC address format for VRRP, and this is nothing but the hexa value of the group, HSRP group. Regarding the multicast address, in the case of HSRP, it was .2 and .102, but in the case of VRRP, it's going to be .18. So we have version 2 which supports IPv4, we have version 3 which supports IPv4 and IPv6. Okay, the multicast address is this for hello and the election mechanism. One additional point for VRRP is it is having its own transport protocol. Okay, so in the case of HSRP, we do not see any protocol number. So this is a UDP number. Okay, so for a HSRP, this is UDP protocol number. This is a UDP protocol number in the case of HSRP. In the case of VRRP, it is going to have its protocol number 112. Okay, so we will see this in the packet tracer as well. Regarding to the timers, it's going to have 1 and 3 seconds. Okay, the default timer is this, and yes, there is few more additional concept in VRRP. Okay, so let's say in case of HSRP, what would be our virtual IPs? So let's say this is 1.1.1.1, this is 1.1.1.2. Now what would be the HSRP IP? It would be 1.1.1.3. Agree? But in the case of VRRP, let's say this is 1.1.1.1 and this is 1.1.1.2. In the case of VRRP, I don't have to take that third IP. Okay, this itself can be your virtual IP or the virtual IP for VRRP. Okay, now let's say you are making use of the same physical IP as your VRRP virtual IP. In this case, your priority by default is going to be 255. Okay, in this HSRP it was 100 because we were taking up the third additional IP as a virtual IP, and by default it used to trigger up the priority to be 100. In the case of VRRP, your physical interface IP itself can be configured as standby, and in such scenario the priority by default is going to be 255. Now let's say in some scenarios you do not want the real interface IP, you still want that additional third IP. Okay, let's say you want the third additional IP which should act as a VRRP. Now in this case the priority is going to be by default 100. Okay, now that's a change which we have to observe while doing the lab. Okay, but from the theoretical point, just understand, when I am making use of the real interface IP as a VRRP standby IP or virtual IP, by default the priority is going to be 255. Okay, but let's say I don't want my physical IP acting as VRRP, I still go with the third additional IP 1.1.3. Now in this case the priority by default will be again 100 on both the side. Okay, and we can just change and we can just go around with the behavior of master and slave. So that's something which I have written over on this points. Okay, load sharing is again very similar as per your HSRP. Okay, you just can make master for few VLANs on the first router. Similar way you can make masters on the second router, just you have to change the priority values. Okay, these are steps to configure V2. Okay, I'm going to do this, so then you can just refer back. Okay, and from this diagram point of view we have configured VRRP. Okay, so this is the first point where I configured VRRP. So the second one takes up the master role. Okay, so in this case it's 110. Okay, and by default it's 100. So that means they have not considered the real interface IP to be the virtual IP. It might be they have taken the third IP. So in this scenario the priority will be your 100. Okay, let's say if they would have taken the physical interface IP, then the priority was shown as 255. So in this case what happens is, when you enable VRRP, the MAC address is going to generate your MAC address table are now nothing but the VRRP MAC address table. The election will happen between the two. They will go through the init, master and slave state. Okay, they'll go through these three states and then they will decide who has to be master and who has to be the backup. So based on the priority, this will win the election. Let's say if the priority was same. Okay, so let's take an example when priority of both are same, 100 and 100. Now who must or who will win the election? It's your highest physical IP address. Okay, so let's say the physical address of this was 1.1.1.2 and this was 1.1.1.1. Okay, and I just enabled VRRP. Now who is going to become master? It's this router because of highest IP address. Okay, just considering the fact that priority, we are not changing the priority and we are just keeping the default priority, that is 100 and 100. Now the decision will be based on the IP address. But if you are bringing the concept of priority, you just made the priority of 110 here and you kept it 100. Now the IP address is not a point to be considered for master and slave election. It will be your priority. The first preference is priority. If the priority is same, then the next tiebreaker here is the highest interface IP address. Okay, so based on that, the master slave election will be taken up. Fine. So let's go to the next step. Okay, so this is the three states of VRRP. It's init, master, and slave or backup, whatever you can call. Okay, so let's say I have two routers. Okay, so this was elected as master and this was elected as a backup. So for some reason this goes down or this comes up as a master. Now let's say this again comes up after a few couple of minutes. Okay, now the re-election will happen. So what happens is this master will be put up into init mode, and now this over here, it will start from the init mode to the next mode, whether master or slave, and the election will happen and then they will form. So it's much more faster because we don't have multiple states in the case of VRRP. Like in the case of HSRP, we had init, listen, speak, and then decide whether it's going to be active or standby, right? It used to take some extra delay. But in case of this, if there is re-election, they are just going to put back into init state. Okay, and then they are going to decide who is master and slave, and then the things will happen. So only fallback is just put into init state whenever they're doing some recalculation, reconvergence, or a master backup election. They just put their state into init, and then once the priority and all other factors are being considered, then they will just decide who is going to be master and who is going to be the backup. So a simple process in case of VRRP. Okay, regarding the configuration, again nothing rocket science, very simple command. Just go to the interface, have your IP address configured, okay, and just configure the VRRP. So what I'll do is I'll do two things now. One, by considering the real interface IPs, and in the second scenario, I'll take the third IP, the one which I was trying to explain. Okay, so as you can see from the packet, they are just between init backup, and if they just want to put back, it's again going back to the init state. Okay, so this is with regards to the next version, that is version 3. So let's quickly do a lab over here for VRRP version 2. So I have the configurations with me. So let's see if this is real IP. Okay, so in this case, it's a real IP. Okay, so let's do for the real interface IP. So what I'll just do is I'll just reload these two devices so that my HSRP configuration get flushed up. Okay, I don't have to manually take down the no commands, all those things. So by default, a reboot will help me to flush out the HSRP configuration, and I should be good with the new configuration. Okay, so if you see from my network diagram, so what is the physical IP over here? It's .1 and .1, right, with respect to two VLANs, VLAN 1 and VLAN 40. So for VLAN 1, I'm going to consider the physical IP itself. I'm not going to consider any additional IP. So it's going to be .1 configured on both the side. Okay, so whenever you're going to make this router as a master, so let me just write it. So for VLAN 1, I'm going to make this router as master. Okay, and I'm going to take the real interface IPs. So that's possible in case of VRRP. So let's do this and let's see the packets. So I'm over on R19. Let's go to configuration T. Let's go to interface E01.1. Let's define the VRRP process, VRRP 1, okay, 1 for VLAN 1. And what is the IP address over here? So IP address is nothing but the real physical IP. So I'll just take this, okay, I'll paste it over here. So I have the VRRP configured. It says VRRP state change from init to master. So that's the expected behavior. Okay, I'm not going to configure preempts because preempts are by default configured. So I can do a quick check here. And this is the command for VRRP. Okay, so if you see, as of now, I just have one configuration and preempts are already enabled. Even though I have not added up any additional line, the preempts are enabled. And what is the priority? When I take the real interface IP, it's going to be 255, not 100. Okay, 100 is in the case when I'm going to consider the virtual IP. Okay, in the case of virtual IP, the third IP, the priority will be taken up as 100 by default. But in the case of real IP, it's going to be 255. And regards to the timer, it's 1 and 3. Okay, which is again a faster timer when compared with HSRP versions. Okay, fine. So this is a configuration I did on one side, and what is the status now? So I don't have any. Okay, do show VRRP brief. Okay, now you can see few things here. That is, we have interface, we have the group getting configured for VLAN 1. We have priority. This is the time for the down interval. Okay, now this is a new component added up in the case of VRRP. Okay, this actually represent as owner. Okay, the full form here is owner. So if you need a different contrast, so let me write it once again. Okay, so what is owner? So when you have master elected up, now this will show up itself as owner. Yes. Okay, similar thing if you see on the second, it will be shown up as blank, because for VLAN 1 or group 1 you already have master, and then master is going to have as is going to add yes. Okay, in the case of the election of master device, it's going to add additional s. Now this is preempt, so by default it's enabled. It has taken up the master because the other device is still not configured, so by default it has taken itself as master. This is the master address, this is the group address. Now let's configure the second box. Okay, so when you have the real interface acting as your virtual IP, so you have to make use of the same IP address. Okay, so let's go to interface E1.1 VRRP 1. What is the IP address going to be? It's going to be 172. So let me just quickly take it from here. Okay, and now I believe there will be some election going on. So let's see what happening. Okay, now this is not a owner. Okay, the reason is it's acting as a backup. What about over here? So if you just check, it has taken up the ownership. Priority is 255. Okay, and if you see here, the priority is 100. The reason is the physical interface is from the different device, not from this device. Okay, so whenever you are making use of any other IP other than its own interface IP, by default it's going to be 100. This is going to by default take it as 255, and it's going to take the it's going to win the election. okay, because the real IP is associated with this router, and by default you're going to get a higher priority, 255. So mandatory this has to be the master, because there cannot be anything above 255. Okay, on other side, as soon as you configured VRRP, it took as 100. Okay, because this 10.1 is not its own IP address. The IP address of this was 10.2. Okay, now let's say if I make it as 10.2, now in that case this interface will have a priority of 255, and if I make 10.2 configured on the second device, it's going to have the priority 100 in that scenario. Okay, so it's always like when you have the real interface configured, then it's going to take 255, and when it's some additional IP, some virtual IP or a real IP of any other devices configured on the second box, then it's 100. Okay, so let's see the do show VRRP command. Okay, so it says its local preempts are enabled, priority is 255. It says virtual IP is this, virtual MAC is this, priority is this. Okay, let's see the election. Let's see what happens if I bring this down. So does it take up the master role? State is master. Okay, from backup it moved on to the master. Fine. Now let's say I just take down, or I just bring up from no shutdown to I just bring up from the shutdown mode. Let's power it on, or let's make this interface up. Okay, by no shutdown command. Now because of this priority, it's going back to take its role once again. So it once again takes up the master role, and this will put up into the backup state. Okay, and the reason is we have preempts and we have priority setup. So on this first router we have a better priority, and we have this preempts by default configured. Okay, so it's going to send the new packets, and it's going to take back the role of master. Now from the point of testing the behavior, what I'll do is I'll first turn this off. Let's open up the edit config, and now the virtual IP is .1. Okay, that's the IP which I'm taking up. Okay, so let's save this. Let's power it on. So let's take the console. Okay, so let's give it a try by pinging 8.8.8. Okay, it's reachable. Let's see the hops or the packet flow direction. So let's see on which path is this packet being taken up by default. So it went to the switch forwarded it to this. Okay, because this is acting as a master. This is acting as a master because the priority is 255 here. Okay, so let's shut down that interface. Let's put up into shutdown mode. Now let's see, do I still have a reachability? Okay, now let's quickly check the trace route. Okay, because as we know, there's a glitch with GNS. Okay, so ping is not a right way to check the packet flow. So let's check it out with trace route. So trace route will show me on which path is this packet being sent. Now it's sent to 10.2. Okay, so the switch is making the decision over on the second path, that is over on this path. Okay, and if you go with the packet level of information, so how is this decision made? This decision is made because of the switch. Okay, so if you see the MAC address table here, so what is the VRRP IP here? Okay, so this is your VRRP MAC address, okay, the first one. So let's see on which direction is that pointing. So it says it's binded up with this now. True, okay, because this is down as of now. So it's binded up with this. Now if you go to the second box, second switch, so let's see where is the VRRP mapped. Okay, so here this is the VRRP MAC address, and it shows its map associated with 01. Okay, now that's over here. So that's how your packet is forwarded to the router 2, or the second path has been taken up. Okay, and this is acting as a master at the moment. So let's quickly check that. Okay, so that's a R20, and if I do show VRRP, now this is a master. Okay, let's revert back. So let's say for some reason my R19 comes up and it has taken back the master role. Okay, so let's see, show VRRP. It has taken the master role, and let's quickly check the trace route once again. So let's see on which path is the traffic flowing now. So this is a drop because of ARP broadcast. Okay, now it took the 10.1. Now where is 10.1? 10.1 is over here. Now because of your VRRP master role. Okay, let's also check the MAC address behavior. Okay, because if we know that it's because of the MAC address, so let's see how the MAC address is going to uh, manipulate the flow. So this is a VRRP MAC address, and it says it's binded up with this interface at present. Okay, now that's nothing but this, and that's how your traffic is flowing over here. Now interesting fact is it was very instant, right? So when the switch says that the traffic has to go on this direction, it was binding up on this direction. Now let's say the original path or the original device was restored, the MAC address was started mapped with this. Okay, it's no longer mapped on the second path because this is a best router. Now what is that which is actually coming into the picture, and it's uh, making these changes so instantly? Okay, so let's check from the packet tracer. Let me show if I can show something over here. Okay, so it's because of the gracious ARP. Now this is one type of ARP, and what is the work of this gracious ARP is, let's say from switch point of view, switch 1. Okay, as soon as there was a failover, as soon as this was put into the blocking state, or let's say this was the new path, now the gracious ARP comes into picture. It is going to remove all the older entries. Okay, the older entries, that's nothing but which is associated with this. It's going to flush it. It's going to bring the new mapping. Okay, now this MAC address is going to get mapped with this interface. Now who is going to do that? It's your gracious ARP. Now there is one type of ARP which is also seen in almost every failover concepts. Okay, like when you have two ASA firewall, and if you are having a failovers, okay, now which is taking the responsibility of flushing the older data and bringing up the new data. Okay, if you just go with the theoretical approach, your MAC address will have 300 seconds of hold timers. Okay, so let me show you. Show MAC address aging time. So by default, your MAC address table will hold any bindings for 300 seconds. Now 300 seconds is like your equivalent to, let's say, 5 minutes something, 16 to 5, yes, 5 minutes, right? But did we wait for 5 minutes? It was very instant, right? It's because your gracious ARP is coming into active role. It's removing all your previous older entries, the bindings between the MAC address and the physical switch port, and it's bringing in the new mappings. That's why the traffic flow was instant, right? You just did a shutdown on one side and the packet was started flowing on the other side, right? So that's in the backend what's come into picture, and it start triggering up, or it start binding up the new port. Okay, so this was regards to VRRP version 2, but yes, I also have version 3. Okay, so what is the difference between version 2 and version 3? So I have made a columns, so it's based out of multiple factors. So as per RFC, the documented natures. Okay, so this is a documentation number for version 2, this is for version 3. What about the protocol? So version 2 is going to support just V4, whereas VRRP V3 is going to support both of them. Just a minute. Okay. Okay, regards to timer, it's in seconds. That's 1 and 3 seconds by default. Okay, whereas your version 3 are going to be in the milliseconds. The multicast address for version 2 is this, whereas the VRRP version 3, the multicast is this for IPv4, but it's going to be different for IPv6. Now this is the IPv6 address. Okay, this is not a MAC address. Don't get confused with that numbers or whatever you see on the screen. Now this is not a MAC address. It's a IPv6 IP format. Okay, so let me write it over here. IPv4 is 32 bits. Your MAC address is 48 bits, and your IPv6 is 128 bits. Okay. So in this case, this is a IPv6 address. It's not a MAC address. So for virtual router ID, in the case of IPv4, it's going to follow this pattern. And as we discussed in case of HSRP V2, when I have a IPv6 support, the MAC address was also changed to accumulate all your 4095 groups, right? So in similar way, this over here also over here it's going to be this pattern. Okay, pattern different than your IPv4. IPv6 is going to have a different pattern. Preempts are configured by default on both the case. Okay, now it's going to be same priority, but your higher IP is going to win the election, right? So when I have two routers, in the case of VRRP, preempts are by default configured. Okay, so the decision now will be based out of on highest IP. So whichever is having highest IP will win the election. Whereas in the case of V3, it's your higher priority will take up the preempt. Okay, which is very similar for both of them. Okay, regarding VRRP enabling, your VRRP version 2 has to be enabled on interface. Okay, so I just went to interface E0/1.1 and then I enabled VRRP 1 IP and so and so. But in the case of V3, it's done on a global way. Okay, so the command will be FHRP VRRP globals. Okay, and that's how I enable VRRP in version 3. So let's quickly check the lab and we should be able to wind up this. Okay, so this is all about the steps to configure. Yeah, this is the command that I was talking about. This is a global command. Okay, so this is a global command in the case of VRRP version 3. These are the instructions to bring up version 3. These are the verification. Okay, so this I'll take in the next class. So let's do the lab for VRRP V3 now. Okay, so I have taken up the commands with me. So let's go to the lab. Okay. What I would prefer is I would prefer to reload this so that the previous configuration get flushed out and I just reconfigure whatever I need to do. Okay, so the devices are up. Let's enable the version 3 VRRP. Okay, so as I told you, it's a global command. I don't have to go to interface and then enable. I will be enabling it over on the global configuration. Okay, so let's say the command would be FHRP version VRRP. If I do a question mark, I can bring up V3. Okay, V3. So this is how I enable V3. Now let's go to interface E1.1 and let's define the VRRP IP now. So let's say VRRP 1 and okay, 1 second. Okay, so as of now, I just cannot bring this. Okay, I just cannot bring this because in the case of version 3, the commands are different. So first I have to go to VRRP 1 address family. And what is what I'm trying to configure? I'm going to configure IPv4, and over here I have to define my VRRP property. So let's say so let's just do a question mark. Okay, so what is the VRRP address? So let's give an address here. Okay, so let's say it's again the physical IP that I'm going to consider 172. So let's take it up from here. So let's paste it here. Okay, so this is the physical IP that's going to act as my VRRP version 3 IP as well. Okay, I don't have to enable any other things. By default, priority now will be 255 for this, and preempts are by default going to get enabled. So let's quickly check that. So as I told you, it's IPv4 capable now. Priority is 255. Yes, this is a owner. This is a master device. Preempts are configured. Okay, I do not have any other device which is running as of now for version 3. Okay, so let's quickly also make changes over on the second box. So let's say FHRP version VRRP V3. Now let's go to the interface E01.1. Let's bring up the VRRP1 address family IPv4. Let's define the IP address, which is once again the IP address of this physical interface. Okay, I'm not going to configure any priority, neither preempts, and in the backend the packet levels are very similar to your version 2 VRRP. It's only init backup or init master. Okay, so let's see the states now. So this has taken up backup state, and this is not a owner. Preempts are configured. This is the master router IP address. Okay, this is a IPv4, and if you check from this side, show standby brief, show VRRP brief, this is going to be your owner and this is going to be master. Okay, and the packet flow is very similar. Okay, now let's quickly check the flap over here. So let's say I have 1.1, and if I just shut it down, so it's going to be just a fraction of second to make this as master. Okay, and in the back end your on your switch side, it's your gracious R which will take down the previous association and it will bring up the new association. Okay, and then your packet are just like in a milliseconds are going to take the second path, even if the first path is down or due to some issue. It's going to be just a few seconds for your packet to take the second path. Okay, so let's see the different packets here do show VRRP. So this is interface down. So let me check for this. So this is master. This shows me the duration, virtual IP. This is a MAC address. This is the advertisement interval, which is in milliseconds. Okay. Preempts are by default. Priority is 100 because that's the other device IP which is acting as a real. Okay, so in this case this will be 255 because it's a in owner mode, whereas this is just a for this interface it's just a virtual IP only. Okay, this is a master, this is an advertisement. Okay, regarding the packet flow, so in the case of VRRP, it says this VRRP router owns the virtual router's IP address. Okay, there is no authentication enabled. If there was authentication enabled, the checksum value will be calculated. Okay, so checksum is associated with the authentication factors. What is the protocol number that we discussed? So it's going to be 112 in the case of VRRP. It has its own protocol. Okay, and the MAC address is shown here. These are the IP headers. Okay, DSCP. These are all the different IP headers, TTL values. So this is an actual payload. The payload or the data here is a VRRP packets. Okay, so it says it's on version 2. It has a packet type, the version number, the advertisement, router ID, all other relevant things with respect to VRRP. Okay, let me see if is there anything that's pending. Okay, so it's fine, we just covered everything. And yes, regarding to the tracking, it's very similar to the HSRP tracking. Okay,